So in this video, we're going to begin to look at absolute value inequalities. So we've already been studying equalities. So remember, inequalities are going to use the less than, the greater than, the less than or equal to, or the greater than or equal to sign. So we're going to have problems that have an absolute value as well as these things. So before we start just solving problems, I kind of want us to understand what is going on. So if we remember the absolute value, when we talk about the absolute value of x being equal to 3, what we're really saying is that the distance from 0 to x is 3. And if you remember when I taught the absolute values, if you think about it, if here's 0, if I'm going a distance, let me put a couple more check marks on here. So -1, -2, -3, -4, 1, 2, 3, 4, 5. So if we're going a distance of 3, that means I could have went 3 this way to -3, or I could have went 3 this way to +3. So that's why we were getting before the answer to x equals 3 would give us two answers, right? That positive answer and the negative answer. So now what we're going to do is we're going to look at the absolute value of x. Let's say that that was less than 3. And so if we're talking about the absolute value of x being less than 3, we're talking about, I want all the things that are 3 or smaller. So again, if I label these, -1, -2, -3, -4. So if we want all of the things that are smaller than 3, we're talking about all the numbers this way. So the distance from 0 in this case is smaller than 3 up until -3, and we would put an open circle. And we could go this way all the way up until +3. So this, when we say the absolute value of x is less than 3, we're trying to say that the distance from 0 to x is smaller than 3. So up here in my first example, there were just two answers, 3 and -3. But down here, there's all of these points. Every single one of these points in here is an answer. And so this is where we have to use that interval notation. And so since there's not an equal to sign down here underneath the inequality sign, I am going to use parentheses. So we're going to write our answer here. It would be from -3 all the way to 3. And we could do a similar thing if we were talking about greater than. So let's say I looked at the absolute value of x is greater than or equal to 3. So again, if here's 0, and I'll put a couple marks here, -1, -2, -3, -4, 1, 2, 3, 4, 1, 2, 3, 4. So if I want to be greater than or equal to 3, so this is again saying that the distance from 0 to x is greater than, that's a terrible looking greater, the word greater than 3. What that means is I have to at least start out here at -3 and out here at 3, but then I can keep going. I just need to be bigger than this. So if I was over here at -4, well, that distance is bigger than 3, and I would keep going this way forever, and I would keep going this way forever. And again, there are a lot of answers in here. And so if there's a lot of answers in here, I have to think about how do I write them? And again, we have to write all of these answers, and so the way to do that is, again, that interval notation. So the thing you want to remember is that way out on the left-hand side is -infinity, and way out on the right-hand side is +infinity. So my interval notation is going to be minus infinity to -3. And then I'm going to use a bracket. And the reason I'm going to use a bracket is because right here it was a closed circle. Union, right? Remember we used that little U for union. And then again, here's that closed bracket. So closed bracket, 3 to positive infinity. So another thing to notice is we can solve these absolute value inequalities in a similar way to how we solved the absolute value equalities. So if you remember in the equations, we split the problem into two pieces. We can do that in these problems too. So I'm going to go back and look at the exact same problems that we just did. So we're going to solve. The first one here is the absolute value of x being less than 3. And so a couple things we need to remember. So when we did solving the absolute values before, we isolated the absolute value, which I have the absolute value here isolated. And then what we did was we split it into two problems. So we split it into a negative case and we split it into a positive case. So I'm going to write down the positive case first. So the positive case here would be the x is less than 3. Now, when I go to do the negative case, I actually have to take this inequality and I have to flip the sign. So it was a less than, so it's going to turn into a greater than. And then I can put -3. And you might go, gee, that's real weird. Why would that be? So essentially what we're doing is we're dividing both sides by -1. And remember, when you divide or multiply by a negative, you have to flip the inequality sign. So that's why it's happening. So you want to remember when you split the absolute value inequalities, you're just going to flip the sign. And now what I'm going to do is I'm going to graph each of these inequalities on a number line. So here's 0, here's -3, here's 3, keep going. Okay, so the first one that I'm going to graph is going to be this one here, and it says x has to be greater than -3. So I would have an open circle at -3, and I'm going to go all the way to the right. And remember, open circle is the same as parentheses, so if you're used to writing it as a parentheses, that's okay. And then this one over here, I'm going to have an open circle at 3, and it's x is less than 3, so we're going to go all the way this way. And then our answer is going to be where these two overlap. So these two overlap from -3 to 3. And that's the same thing we got before when we were thinking about this problem in terms of distance. So let's try another one here. So maybe we have the absolute value. I think I did the absolute value of x was greater than or equal to 11. So again, I'm going to split it. I have the negative and the positive. So one case, it's going to look exactly the same. X is greater than or equal to 11. The other case, we're going to have the x, but then remember we have to flip that sign. So it's going to become less than or equal to -11. And again, we're going to draw these. So here I have -11. Here I have +11. And so if I graph this first one, if x is less than or equal to -11, we would have a closed circle at -11, and we would go to the left. A neat little trick that I use is you're always going in the direction the arrow is pointing. And then if x is greater than or equal to 11, I would have a closed circle on this side, and I'd always be going to the right. And now if you notice, nothing overlaps, right? So if nothing overlaps, then what I have to do is I actually have to take just both of those pieces. So if they overlap like they did here, I'm just going to take the overlap, but if they don't overlap at all, I'm going to take each of the parts. So we're going to take this piece and this piece. So this first piece is going to be from -infinity to -11 with a closed bracket, union, close bracket, 11 to infinity. So there are two kind of special cases And there are things we just kind of need to be on the lookout for because this method doesn't work. But if we happen to ever get the absolute value of, it doesn't just have to be x, the absolute value of a bunch of stuff being greater than or equal to a negative number, then if you think about it, the absolute value here, so if you remember from the absolute value equations, negative numbers just were like no solution. But in this case, that's not always true. If it's greater than or equal to a negative number, then when you take the absolute value is always positive. So I have this always positive number being bigger than or equal to a negative. So this is going to be all real solutions. And the way that we mathematically write that is minus infinity to infinity. So it would be the whole entire number line would work. On a similar note, if we ever had the absolute value of a bunch of stuff being less than or equal to a negative number, this is, again, the absolute value is always positive. So if you're always positive and you're less than or equal to a negative, this would be no solutions. So for example, if I had the absolute value of x bigger than or equal to -3, so e, that would be all real numbers. So minus infinity to infinity. It works even if it's just greater than. If I had the absolute value of x greater than -12. Again, that's going to be all real numbers. Minus infinity to infinity. And if I had the absolute value of x, say, less than -16, that's going to be no solution. So the absolute value can't be smaller than a negative number, but it can definitely be bigger. These problems here, you're not going to see these that often, but once in a blue moon they might sneak up. You might see a problem like that on Alex. Most of the problems are actually going to be more like these ones up here in A and B, and you're going to see that as we go on to other sections.